So ARM has announced some new CPU and GPU cores. I've got videos covering all the different aspects of the launch. In this video, I want to do a deep dive into the C1-Nano. So if you want to find out more, please let me explain. Okay, so let's get into this. The C1-Nano is the successor to the Cortex-A520, and the reason it's a new efficiency core has now been released because all of these are on Armv9.3. So 4 new cores from Arm. We're now looking at this Nano one, the successor to the A520. So where does it fit? Well, certainly up to the medium mainstream tiers, you're going to have Nano cores, what would have been Cortex-A520 cores in previous years. You've got these new C1-Nano cores, and they can feature a lot in a lot of different types of SoC, particularly, as I said, mainstream, even right up to high-end mainstream. You're going to find SoCs with the Nano cores in it. And because it's part of all this group, it's SME2 enabled, using the SME2 unit, which is part of the CPU cluster. I cover that in other videos. And of course, it's Armv9.3. So there are some front-end improvements. So a CPU can be divided really into 3 main parts. The front end, that's the fetch and the pipeline. You then got a core, which as the different instructions go down the pipeline, and then you've got the back end where you're doing the retirement and other stuff like that at the front end. So one of the big changes here, and this is something that was brought in with the Cortex-A76, so quite a long time ago, and has been a feature of the bigger cores, is this decoupled predict fetch pipeline. This allows the branch predictor to guide instruction prefetch. It improves the performance by bringing instructions into the L1 instruction cache earlier, and therefore reduces the time stalled to because of the iCache misses. Also improves efficiency by increasing prefetch accuracy and timeliness. Efficiency improves because you don't have to do the work twice, then you're not using as much power. So that's really good. So obviously ARM has a huge amount of data now from the Cortex-A76 onwards about how this really helps in a core, and they've now actually been able to bring it down into the Nano core and thus improve performance and efficiency. Other front-end improvements also include improvements of the branch prediction, which increases both performance and efficiency as well. Now in the core memory subsystem improvements, there's enhancements to the vector unit power and performance. What does that mean? So even in the C1-Nano, there's a Neon unit, there's an SVE2 unit, and those have been improved for better performance. There are also changes to the memory subsystem, allowing the data prefetcher to improve its performance and accuracy. So overall, the C1-Nano is an Armv9.3 little core, which gives you up to 26% greater power efficiency over the A520 on the same process node. It's got the smallest footprint and yet the highest area efficiency. And improved instruction fetch, because of the decoupled pipeline at the front now, gives a 10% performance uplift in fetch bound workloads. Okay, that's it. I really hope you enjoyed this video. If you did, please do give it a thumbs up. And if you like these kind of videos, then I invite you to stick around by subscribing to the channel. Okay, that's it. I'll see you in the next one.